Hi everybody, thanks for joining me. This is Parker from JESU PREP Champions, and today we're going to cover how to find the perimeter and area of the shapes you need to know for the GED test and the geometry on that. So let's get into it. We're going to start with the perimeter. So there's two main things that you have to know about the perimeter. So the first is the definition. What is the perimeter? Well, the perimeter is just the distance around a shape. And we're going to look at some examples of what I mean in just a second. Now, there are formulas that you're going to want to know that I'm going to show you for how to find the perimeter. And you're going to want to be familiar with these. But if you ever forget these formulas or you don't have them handy, you just simply add up the lengths of each side. So definitely know number 1 and number 2. Maybe put these down in your notes. And so let's look at some examples. We're going to look at squares, rectangles, and triangles, starting with squares. Okay, so we're going to start off by looking at squares. And so this shape here is a square, this big blue shape. Hopefully you recognize that's a square. If not, I have a video on four-sided plane figures where I cover basic squares, rectangles, those kind of shapes that you want to be familiar with. So I'll put that link down below. But anyway, this is a square. And so for a square, all sides are the same length. Okay, and so there are two different formulas that you can use to find the perimeter of the square. So I have written down here P equals 4S. And also P equals S plus S plus S plus S. Now these formulas may look a little bit different, but they're actually the same exact thing. They're both going to give you the same exact answer. So you can pick whichever one you want. Like I said, if you forget these formulas or you space out, just remember that you can always find the perimeter by just adding up the lengths of each side. So let's say that S equals 2. So let's say that we knew that one side of the square was equal to 2, and we wanted to calculate the perimeter. There's really two ways to do it. So we could take this formula right here, which is P equals S plus S plus S plus S, and all we would do is everywhere where we see an S, we would just substitute a 2 in. So we would just do 2 plus 2 plus 2 plus 2. All right, and so 2 plus 2 is 4, plus another 2 is 6, plus another 2 is 8. So this formula would tell us that the perimeter is equal to 8. Now we don't know if it's inches, meters, centimeters, but that's not important here. The point is just to understand how to get this answer. Now you could also do it with this formula here, P equals 4S. So again, all you would do is just take that 2 and you're just going to substitute it in for S. So everywhere you see an S, you would just replace it with 2. So we would have 4 times 2. And I'm just writing the 2 in parentheses to show that we're going to multiply 4 times 2. Now 4 times 2 is equal to 8. And so either way, you're going to get the same answer. So either way, if you use the if you use the perimeter equals 4S, or if you use the perimeter equals S plus S plus S plus S, you're going to get the same exact answer. Now, I recommend, it's a little bit easier to just use this 4 equals 4S, right? It's going to save you time on the test, because all you have to do is do 4 times whatever S is. In this case, it was 2. That's a lot faster usually than doing S plus S plus S plus S. But it doesn't really matter. You're going to get the same exact answer, and both are valid ways to do it. All right, so that's squares. Now let's move on to rectangles. Okay, so the shape on screen now is a rectangle. And so there are two different formulas you can use to find the perimeter for the rectangle. The first is P equals 2L plus 2W. So L stands for length and W stands for width. And now, of course, as always, you can just simply add up all of the sides. So if you use the second formula, all you do is L plus W plus W. So you're just adding them all up. Now, again, these formulas really, they're the same exact thing. They're just written a little bit differently. And so let's use an example here. Let's say that the width is equal to 2 and the length is equal to 1. Okay, so now how you would do it is you just pick one of the formulas, and for everywhere you see an L, you just substitute a 1 in. And everywhere where you see a W, you would just substitute a 2 in. Okay, so let me just draw an arrow here, and let's write the workout here. So perimeter equals 2 times 1, because remember, we're substituting 1 in for L, plus 2 times 2, because again, remember, we're substituting that 2 in for W. So if we do the math here, we know that 2 times 1 is 2, plus 2 times 2, so 2 times 2 is 4. All right, so we would have this 2 plus 4, which equals 6. And so we would know that the perimeter is equal to 6. Okay, And so that's how you would do it using the formula where you use multiplication. But you could also, of course, just add them up, right? So if we did that, we would do 1 plus 1 plus 2 plus 2. All right, and again, everywhere we see that L, we're just putting a 1 in, and where we see the W, we put a 2 in. So we would do 1 plus 1, which is 2, plus another 2, which is 4, plus another 2, which is 6. Okay, so those are the two ways you can calculate the perimeter of a rectangle. Okay, perimeter of a triangle, and so I'm going to go kind of fast on this one because it's pretty simple. All you're going to do is add up the sides of the triangle as with the other shapes here. And so I have the formula here, which is A plus B plus C. And so you're just adding the sides up. So let me give you some numbers here. Let's say that side A is equal to 1, side B is equal to 2, and side C is equal to 3. And on your test, you're probably going to get some harder numbers, but let's just keep it simple to get the concept. And if you want, you can pause the video and try to find the perimeter of the triangle. Okay, whether you pause the video or not, let's go over how to do this. So we're just going to substitute our numbers in. So wherever we see an A, we're going to substitute a 1 in, and wherever we see our B, we're going to plug a 2 in. And where we see our C, okay, we're going to put a 3 in. All right, so we have 1 plus 2 plus 3. And so 1 plus 2 is 3, plus another 3 is 6. So the perimeter of the triangle is 6. So again, not much to it. You just add up the sides of the triangle. Okay, so now we're going to move on and let's switch gears here and talk about the area. Okay, we're on to area now. So first of all, what is area? Well, there's several different ways to think about it, but the most helpful way, I think, is to think of it this way. Area is a measure of how much space there is on a flat surface. And so this would be like a square, a rectangle, triangle, parallelogram, or a trapezoid. And the other thing to know is that we measure the area in square units. So this could be square feet, square inches, square centimeters, doesn't really matter that much, but just keep that in mind. So now let's go through some examples here of the different kinds of flat figures that you'll need to know how to calculate the area for. Okay, so let's first look at the area of a square. But before I do that, one way to kind of conceptualize area is to just think about a sticky note and a sheet of paper. So obviously, a sticky note is much smaller than that sheet of paper, so we would say that the piece of paper has a much greater area than a sticky note. So hopefully that kind of helps you conceptualize what we mean when I say that area is a measure of how much space there is on the flat surface. So with that being said, let's move on to looking at the area of a square, because the most important thing is to know how to use these formulas really to calculate the area for your test. So the area of a square is very, very simple to calculate. So we already know that for a square, all four sides are of the same length. And so there's two ways to think about the formula. So you can think about it as side times side or as side squared. They're the same thing. So when I write this side squared, that's the same thing as just writing side times side. So however you want to think about it. And so let's just say that maybe this is equal to 4 inches. And I'm not going to use the units too much in this video just because it's not really that important, because it's usually pretty straightforward, but I'm going to do it here in this case just to show you, just to illustrate what I mean by point number 2, that we measure area in square units here. So let's say that this is S equals 4 inches. So if you want to find the area of a square, you would just take that 4 and you're going to plug it into the formula. So you would do 4 inches, and then this is all squared. And so 4 squared is 16, and inches squared is what the unit would be here. All right, so the answer to this would be 16 inches squared. And again, all we did was we just realized that sine is equal to 4 inches, and so we just plugged that in, and we did 4 times 4, or 4 squared, however you want to think about it. Two different ways to think about the same thing. We got 16 inches squared. Okay, so that's pretty much all there is to know about the area of a square. Let's look at the area of a rectangle. So just like the square, the rectangle is pretty simple to calculate the area for. You just have to know the formula, which is area is equal to length times width. And so I don't want to confuse anybody, but I did this for a point here. I wrote this L in cursive. Now sometimes you'll see the L written in cursive, or sometimes you might just see the capital L like in regular English. It doesn't really, it's all the same thing. It's just sometimes you'll see it written a different way. So I just wanted to make sure I wrote this in cursive at least once, just to show you that when length can be written as a cursive L or a regular L. Doesn't really matter. But anyway, this is the formula here. So let's say that the length was maybe, I don't know, 10 feet or inches, whatever the unit would be. And let's say that the width is maybe 2. Okay, so all you would do is you would just plug this into your formula. So if our L is equal to 10, we would just do area is equal to 10, and then we would multiply that by 2. And I'm using the parentheses to show multiplication here. So we do 10 times 2, and that would be 20. And again, as always, we would take the units into consideration. So for example, if this was 10 inches and this was 2 inches, the answer would be 20 inches squared. Okay, we're on to the parallelogram, and parallelogram is a bit of a tongue twister to say, so I might botch it during this explanation, but you'll know what I mean. So basically, parallelograms look like this. So I'm going to highlight it here with this box, and I cleared the notes out of the way just to give us some more room. So hopefully you wrote those down if you wanted to. If not, you can always rewind the video and get them. But anyway, so for a parallelogram, you have to recognize it first of all, because it's in everyday life where we more commonly see squares and circles and rectangles, but not often parallelograms. So this is what one looks like. And I also included this rectangle down here just because I want to make the point that all rectangles are actually parallelograms, but not all parallelograms are rectangles. Okay, and so what you want to realize here is that they both share properties. So with the parallelogram and the rectangle, they are both four-sided plane figures. The internal angles of a parallelogram are going to add up to 360 degrees, and the internal angles in the rectangle add up to 360 degrees. And so also they both have two sets of parallel sides that are the same length. So let me show you what I mean by that. So I'm just going to use slashes here, right? So I'm going to mark off in our parallelogram, these sides here are parallel and they're the same length as each other. And these lines here that I'm going to mark with two slashes. Okay, so the lines here with two slashes are also parallel and they are also equal in length. All right, so for a rectangle, right, there's also two sides that are parallel and equal in length. Okay, there's two sets of sides that are parallel and equal in length is what I meant to say. Okay, so, and I indicated those with slashes. So again, these sides that have two slashes, these sides are equal in length to each other. Now, the sides with the single slash are also equal in length to each other. Okay, so we've got these two sets of parallel sides that are of equal length. That's a common property of the parallelogram and the rectangle. Okay, so the main difference here is that in our parallelogram, okay, we have these four internal angles, and the angles are going to be, the angles that are across from each other are equal to each other. So I'm drawing this arrow here to show that these two angles are going to be equal to each other. They're located opposite to each other, but they are equal to each other. All right, and so this is also true of these two internal angles. So these angles are equal to each other in measure, but they are opposite to each other on the parallelogram. Okay, and so all of these angles, if you add these all up, they'll equal 360 degrees, but the opposite angles are equal to each other in measure. Okay, now on the difference though is that on the rectangle, okay, all of these angles are 90-degree angles. So all of the angles, there's no variation for a rectangle. They're always going to be 90 degrees 100% of the time. Okay, and so as I said, all rectangles are parallelograms, but parallelograms aren't necessarily rectangles. Now that's not a super important point for the test, but I just wanted to include that. If you want me to expand on that more, just let me know in the comments, and I'd be happy to explain it more. But for the purposes of the test, what you need to really know is how to calculate the area and how to calculate the for the parallelogram. So let's do that. So the formula you need to know is the area equals base times height. So I've highlighted that here. Okay, and so usually for a rectangle, you're going to see it written as length and width, as I pointed out here. You're not usually going to see it written as height and base, but they might write it that way. But more commonly, it's going to be length and width. But I just had it displayed this way because I want to drive the point home here that if you've got a rectangle where the height and the base are the same as the height and the base in a parallelogram, the area is going to be the same for both the parallelogram and for the rectangle. And so if you look at this parallelogram here, right, look at how, if we kind of just took this parallelogram and just kind of crunched it down, it would look like this rectangle, right? So the parallelogram, again, it can be made into that rectangle, so to speak. Okay. And so now let's look at the parallelogram, let's look at the height here. So usually the way that they're going to write the height is they'll find this line here, and they're usually going to dot it like this. You're usually going to see it on your practice problems or on your exam. It'll usually be dotted like that, but not always. It could be a solid line, or they might write it on the edge out here. So in this case, we see this arrow here, and we see this H kind of on the end of the figure here. Okay, but these lines are going to be the same thing. Okay, they're the same exact length. So let's just make the height equal to 2, and let's just pick the base. Let's just say, I don't know, 3. Okay, and so now all we have to do is just plug these into the formula here. So we've got the area is equal to base times height. So area is equal to the base, and the base is equal to 3. All right, times the height, which is 2. All right, and I'm using this little dot now to show multiplication. There's different ways to write it. I want to mix it up here a little bit to show you guys different ways that they might write it on the test or in your practice problems and in your workbooks. So 3 times 2 is equal to 6. So the area in this case would be 6. Now, the point that I was trying to make here is that, let's say that for the rectangle, we had the same base, right, and the same height. So if the base was 3 and the height was 2, for this rectangle, we would get the same exact area, okay? But anyway, the most important thing here is just to know how to calculate this area of the parallelogram, and to do that, you'll have this formula, and you're going to have a formula sheet, so you're not necessarily going to have to memorize this formula here, but just know how to use it. So that's the parallelogram. That's how to calculate the area. It's pretty simple. Okay, we're on to the area of a triangle. And so the formula, simply put, is area is equal to half times base times height. Another way to think about that is area is equal to base times height divided by 2. Okay, so we could also write that as area equals base times height divided by 2. Either way, it's the same thing, just two different ways of writing it. And so why does that make sense? Well, I have down here the parallelogram that we just looked at, okay, but now I've cut it in half. So if you kind of take the parallelogram and draw a line here to cut the thing in half, you'll see that the parallelogram can be split up into 2 different triangles. So I did my best to color in one of those triangles here in dark so that you see one triangle in dark. And so to illustrate the other triangle, let me just kind of make a dotted line right here. Okay, so the parallelogram can be split up into 2 different triangles. And we already saw that the area of the parallelogram is equal to the base times the height. Now, since the parallelogram can be split up into these 2 different triangles, right, if we want to get the area of just one of the triangles, what we're going to have to do is we're going to have to take the area of the parallelogram and we're going to have to cut it in half or multiply by half. And that's why we get area equals half times base times height as our formula to find the area of the triangle. Okay, hopefully that makes sense. All right, so I just wanted to give you some conceptual understanding of why that makes sense. Not super important, again, for the test, but that is just to get the concept down here. Okay, so let me clear that out of the way here. And so this would be pretty simple, right? So if I was going to give you a practice problem, all you would do is this would just be another plug and chug. So let's say base is equal to 4, height is equal to 2. Go ahead, pause the video. You can try to find the area of this triangle. Okay, so hopefully this is pretty simple. We're just using the formula area equals base times height divided by 2. And so what we're going to do here is for the base, we know that that's going to be equal to 4. And for the height, we know that that's going to be equal to 2. And I'm using this dot here now to show multiplication. And then the whole thing is divided by 2. Okay, and so 4 times 2 is 8. And 8 divided by 2 is 4. So the answer is just 4. Okay, now a totally valid way to do this would have been to just see, well, we've got 4 times 2 divided by 2. Can't we just cancel these 2's out? And the answer is yes, and that would just leave us with 4. So however you thought through this problem, the answer is going to be 4, but it is a simple plug and chug type of problem. You get that formula and you plug it in. Okay, so this triangle kind of looks like a right triangle to me, where the 2 lines, the base and the height, meet to form a 90-degree angle. They are perpendicular to each other. Perpendicular lines intersect and form that right angle. Okay, but you might also see, you might see a triangle that looks kind of like this. Like there's different ways, and in this case you would just have to know that, hey, well, this is your height here. Okay, and the height just comes down here and intersects with the base to form our 90-degree angle. Okay, so you might see the triangle written a little bit differently. This, like I said, kind of looks like a 90-degree right triangle, but the basics are the same. Just find the height, find the base, and multiply them together, and life will be good. All right, let's keep moving here. Okay, we're on to the area of a trapezoid, and the formula for this is a little bit different than the shapes we've been dealing with so far. Not necessarily harder, it's just a little bit different, and really that's because we have to use two bases here. So the formula is area equals half times the height times the sum of the two bases, and again, you're not going to have to memorize this formula, but it's good to have some practice using it. So the main difference, again, like I just said, is that we've got two bases. So if you can identify the two bases and put them into the equation, it's going to be pretty simple to get the answer. Okay, so we've got four different sides here. So how do we know which of these sides are the bases? Well, we know because the bases and the height are perpendicular. Okay, so again, let me just give you a quick refresher on what that means. So if I take two lines here, let me make a cross. So I've got one straight line going down vertically and one straight line going horizontal. And they cross here, and they cross at a 90-degree angle. All right, this is a 90-degree angle, and that's what these little boxes, they look like. They are 90-degree angles. Those are representing the fact that we've got a 90-degree angle, also known as a right angle. So two lines are perpendicular when they meet at a right angle. Okay, so we know that a side is a base if it's perpendicular to the height. Okay, and so this line here is our height. It's dotted, so let me just trace this so we know that we're looking at the same thing here. Okay, so this is our height. So now imagine if I just took this height line and I just kept going with it, right? I didn't stop, I just extended it. Okay, so now let's look at the base here. So they wrote the right angle in here, so we would already know that this line down here, this little lowercase b side, is going to be one of our bases. Okay, but let's just say that they didn't give us that. All right, so just extend the line here, right, in both directions, and we see that, hey, look, they cross, and it's going to look like you got one straight line going in the horizontal direction and another straight line going up and down or vertically, and they meet here at this little 90-degree right angle, so we would know that side little b is a base. Okay, and so side little a here is also going to be our base. And again, the way that you can tell is if you just take this height and you extend it, and then you just trace this line. You can just do it in your head. You don't necessarily have to write it out, but just visualize this line extending right on and on and on in both directions, and you'd see, hey, look, we've got a 90-degree angle here. This is a right angle. Okay, and we know that because, look, when two lines intersect at a right angle, they are perpendicular. So again, our base is going to be little a and little b. Okay, so make sure that you really see this. So basically, I'd rather you think about it mathematically and think about it in terms of, hey, the lines, when the height and the base are perpendicular, but you can also just kind of look at it visually, right? So usually the bases are just going to be these straight lines. So the line that looks straight is going to be your base, okay? And that's in comparison, let me clear this out of the way here, to the lateral sides. Okay, so the lateral side here, it just kind of goes on and on. See how it looks diagonal? It doesn't look like it's a straight line. Okay, so let's just draw a line in here for the height. Okay, so let's say that this is our height. Now you can tell, look at how the height and the lateral sides, look at where they intersect here, right? So they intersect here and they form an angle, but it's not a 90-degree angle. So that's how we know that this whole side over here, this is a lateral side. This is not a base. All right, same with this side over here. Okay, if you want to test if this little side right here, this side DA or AD, however you want to look at it, okay, you can just trace it. And then at the same time, trace the height. All right, and look at where they cross. So they cross here, right? They're going to make an angle here. We've got angles here, but they're not 90-degree right angles. All right, so that's how you know that those are lateral sides. So you can think about it mathematically, or you can just kind of look at it visually and say, hey, well, this line is diagonal, so it's probably a lateral side. Whereas with the base is flat, right? It extends like this, and the height crosses here, and we've got this 90-degree right angle. Okay, so we've got our two bases. We know that the two bases are the side little a and side little b, and so now all we're going to do is, let me just give us some numbers here to work with. So let's say that a is 2 and b is 3, and let's say that the height is equal to 1. All right, and so as always, you can pause the video and try to calculate the area. Okay, so whether you tried that on your own or not, let's go over it now. So basically all we're going to do here is we're going to take the height, which is 1, and plug that into our formula here, and let's take the bases here. So it doesn't really matter if you use 2 or if you use 3. right? So you can make that base 1, or you could make it base 2. It doesn't really matter. Same with 3. Okay, we're going to make it base 2, but you could just as easily, you could make 3 base 1 and 2 base 2. It doesn't really matter as long as you hit both bases in here. Okay, so now all we would do is we're going to substitute this in here. So we're going to have half times 1, right? Because the height is just 1. And then we've got our base 1, which is 2, plus 3. Okay, and so now what we're going to do is, we know that from our order of operations rules, or PEMDAs, please excuse my dear Aunt Sally if you're not sure what I'm talking about. I've got a video on that I'll link to down below. All right, we know that we want to start with what's inside the parentheses. So 2 plus 3 is 5, and so we've got half times 1 times 5. So now 1 times 1 is just 1, 1 times 5 is just 5, right? So we don't even need to write these ones anymore, and we can just simplify this as the area equals 5 over 2. And if you had your calculator, you could turn this into a decimal, or you could take this, what's known as an improper fraction, you could convert it into a mixed number if you wanted to. You know it's an improper fraction because the top number, which is called the numerator, is bigger than the bottom number, which is called the denominator, but that's not really important here. The point is just to get to this far. If you got to this, area equals 5 over 2, or if you see how I did that, that's the point of the question. So again, you don't have to memorize this formula, but you do want to be familiar with how to use it. It's as simple as you just find the two bases and just plug them into the formula. Not too hard to identify the bases. Again, the height and the bases are perpendicular, and so that's how you know you've got a base, if it's perpendicular to the height. All right, so for most of these questions here, it's pretty much you just have to identify the formula and plug the numbers in and make sure that you do the math right, or plug the numbers into your calculator right, and you're going to get the right answer. So there are some trickier cases though, so we're going to look at 2 trickier cases and then we're going to wrap up for the day, or at least for the video. Okay, so here's our first example problem. What's the area of the shaded portion of the rectangle? So let me just point out here what we're doing here, because my drawing skills aren't perfect. But basically, this shape here is the rectangle. We see the outline of the rectangle. And then the shaded portion is what we want to figure out here. Okay, and so I'll give you a chance to pause the video and try this out on your own. Let me give you a hint though. So the idea here is you want to identify what shape this is. So the shaded portion is its own shape. So I want you to figure out what shape that is, then figure out which formula you want to use, and go ahead and plug those numbers in and get an answer. Go for it. Okay, so whether or not you had a chance to try this out on your own, let's go over how to do this. So the shape that is shown here is a trapezoid, okay? And so hopefully you recognize that we're dealing with a trapezoid. So this whole shaded portion is a trapezoid. So let's recall the formula for the area of the trapezoid, which we were actually just looking at trapezoids more in depth here. But again, you're not going to have to memorize this formula, but you do have to be able to recognize a trapezoid when you see one. So hopefully you were able to do that. But the formula for the trapezoid, you know what, I won't show that. Let me just put a little dot here. So we've got area equals half times h, which represents the height, times the sum of the two bases. So times base 1 plus base 2. So really the trick here is, you know, we've got multiple numbers going on down here. We've got 8, 6, 10, 4, and we've got to figure out which numbers represent the height, which numbers represent bases, and we've got to plug the numbers in, and we've got to do the calculation correctly. Okay, so let me make a little bit of a chart here. So we want to figure out the height, we want to figure out base 1, and we want to figure out base 2, and then we're going to plug these numbers into our formula here. So what we have to recognize here is that not all the numbers that are given to us are really that important. So let's just think through what some of these numbers are here. So what is this 4 telling us? Okay, well the 4 is telling us this portion of the rectangle. Okay, so basically this little portion of the rectangle is 4 inches. That's what that's telling us, okay? But we're not concerned about this portion of the rectangle because this portion of the rectangle is not the shaded portion, right? We only care about the shaded portion. So that 4 is not going to help us, so we don't care about that 4 for the purposes of this problem. So what about the 10? What is the 10 really showing us here? Well, the 10 is basically showing us the length of this portion of a rectangle. Okay, so it's showing us that this portion of the rectangle is 10 inches. Okay, and so if we wanted to figure out the length of if we wanted to figure out the the measure of this side of the rectangle, right, we would just do 4 plus 10, and we'd see that this is a 14-inch length. But we don't really care about that, right? We care about the shaded portion. We don't care about the whole rectangle. So this 10 is going to be very important, and this 10 is going to be one of our bases, okay? And the way that you know it's one of the bases, okay, is because, look, this line over here has to be our height, right? Because the height and the bases intersect to form a 90-degree right angle. Okay, so we see that we're going to have this right angle here. Okay, so if we extended the base and we extended the height, we would have a right angle. So 10 is going to be one of our bases. So it doesn't matter which one it is. You just want to plug it in for base 1 or base 2. Again, doesn't matter which. And so the height is going to be 6, right? And we can see that because this line is the height. It's a straight line going up and down. Okay, and so now 8 is going to be our other base, right? Because if we took this, we extended it, we would see that we'd get this 90-degree right angle. So 8 is going to be our other base. Okay, and so see how these are the only numbers that we really care about. We don't care about this 4. We don't care about this portion of the rectangle. We don't care about this portion of the rectangle. We just care about the shaded portion here. Okay, and so now that we've found these numbers, we would just simply plug these numbers into the formula, right? So we're going to replace this h with a 6, and we're going to replace base 1 with 10, and we're going to replace base 2 with 8 here. So let's do that, and let's see what we come up with here. So area equals half times the height, which we just found is 6. So let me put a little dot here, we'll put 6. And then we've got our parentheses. We've got base 1, which is 10, and base 2, which is 8. Okay, and so try to always go in the order, follow the order of operations rules, which are, please excuse my dear Aunt Sally, the P stands for parentheses, so we want to deal with what's in the parentheses here first. So 10 plus 8 is 18, so we have area equals half times 6 times 18. And so now there are substitutions that we can make here, right? I'm sorry, not substitutions. The word I'm looking for is simplifications. Another word that starts with an S. So we can do a simplification here. Okay, so what is 6 divided by 2? Well, 6 divided by 2 is 3. Okay, so we can cross this out and we can now rewrite the problem as area equals 3 times 18, and 3 times 18 is 54. Now, I didn't know that off the top of my head. I used my calculator to figure that out before we did the problem here. Okay, so you could just do 3 times 18 in your calculator and get 54. Okay, what is the square footage of the grass in the yard? This is your last example, and so the grassy portion is green. So everything in green is the grass, and everything in gray is the driveway. Okay, and I want you to find the square footage of the grass in the yard. 3, 2, 1, pause the video and try it out. Okay, hopefully you had a chance to pause the video, but if not, that's okay too. Let's go over it. So, first of all, what does square footage mean? Well, we know that area is measured in square units. So basically what I'm asking you to do is find the area here. So what is the area of the grass in the yard is basically what the question is asking you to find. So let's think about it for a second here. So I'm going to abbreviate the area of the yard as just Y. Okay, so the area of the yard is equal to the area of the grass, which I'm just going to abbreviate as a G, plus the area of the driveway, and I'm just going to abbreviate the area of the driveway with a D. So the area of the yard is equal to the area of the grass plus the area of the driveway. And so we want to just find the area of the grass. Okay, we don't care about the whole area of the whole yard. We don't care about the area of the driveway. We just want to find the area of the grass. Okay, well, we're going to have to care a little bit in order to get the area of the grass, but that's mainly what we're concerned with. So we want to get this G. This is the goal. Find the G. So we want to get the G by itself on one side of our equation. We want to isolate it. So how can we isolate G on the right-hand side of the equation? Well, we do that by clearing the D out, right? So we want to get rid of the D. We want to get the area of the driveway off of the right-hand side of the equation. So since there's a plus sign in front of it, all right, we want to do the opposite operation or the reciprocal operation, whatever you want to call it, multiple words for the same thing. Okay, you could also say the inverse operation. So you've got G plus D, and so we want to subtract D, and that's going to get G by itself on the right-hand side of the equation. But whatever you do to one side, you have to do to the other. So if we're subtracting D from the right-hand side, you also subtract D from the left-hand side. So we would then rewrite this as Y minus D equals G. All right, so the area, right? So the area of the yard minus the area of the driveway is equal to the area of the grass. Again, the area of the yard minus the area of the driveway is equal to the area of the grass. So to find the area of the grass, we basically find the area of the whole entire yard, subtract the area of the driveway, and that's going to spit out the area of the grass. All right, so hopefully that makes sense. So now let's use our heads here, and let's try to find the area of the yard. So the area of the yard is just going to be this whole entire thing, right? And so this is a square, and we know it's a square because all of the sides are equal here. So the area of the whole entire yard, we can find that by multiplying 30 times 30. Now, why would we multiply 30 times 30? Well, the area of a square, right, is, remember, equal to the side squared. Okay, so side squared, right? Or another way to think about that is the area of the square is equal to side times side. Okay, two ways to think about the same exact thing. So side squared or side times side. Either way, that's how you find the area of the square. So to find the area of the yard, we first note that the yard is shaped like a square, and then we would do side squared. Okay, so we would do 30 squared. All right, and so 30 squared is 900. And I used the calculator off screen. I didn't know that off the top of my head. All right, and so that's the area of the yard. And so now what's the area of the driveway? So to find the area of the driveway, we're going to do the same thing. So first we look at the area of the driveway. We see that it's a square. We know it's a square because all of the sides are equal. All right, and so I could have just as easily written a 15 over here and a 15 up here. All right, I didn't do that though because there's no need to, but yeah, these are both squares that we're dealing with here. So to find the area of the square, what you do is you multiply 15 times 15. Okay, and so we would do 15 times 15 or 15 squared, however you want to think about it. And we would then see that we would get 225. And again, I used a calculator. I didn't know that at the top of my head. So now what we want to do is we just want to substitute these values in here, right? So we want to put 900 in for y, and we want to put 225 in for d. So we're just going to subtract them here. So we do 900 minus 225. And if you use a calculator, you'll see that that is equal to 675. All right, so 675 feet squared is going to be the area of just the grassy portion. All right, so that is the video, so hopefully that makes sense. Let me know down below if there's anything that you'd like me to clarify, any comments, feedback, suggestion. Please like this video and subscribe to my channel for more, and good luck on your test. Let me know how everybody does.